Section, Privacy, Hardware, and the Local Stack. A significant shift is occurring in the argument for local AI inference, moving from mere preference to security necessity. New research from Stanford using the MagPi benchmark indicates that multi-agent cloud systems have a severe privacy problem. When AI agents collaborate, managing writing, research, and analysis, they essentially share a working memory. The study found that private user data leaks to other users 50% of the time in these environments, spiking to a staggering 73% leak rate for healthcare data. This structural flaw suggests that for sensitive data, local, isolated models may be the only truly private option. If local inference is the solution, the immediate bottleneck becomes hardware. A recent intense debate regarding the best sub-$20,000 configuration for on-premise chatbots highlights the divide in the community. The Apple Silicon faction argues for Mac Studio clusters due to unified memory efficiency for large models, while the prosumer camp advocates for stacking NVIDIA RTX 5090s to maximize raw compute per dollar. For enterprise reliability, however, the consensus still leans toward RTX 6000 cards, despite the cost. Software tooling is evolving to meet this hardware demand. Engineers at AMD have released Lemonade, a complete C++ rewrite of their local LLM aggregator. By moving away from Python, they aim to provide a turnkey alternative to tools like Ollama, specifically optimizing for AMD's NPU and GPU architectures, while unifying various inference engines behind a single API. This aligns with a broader community push for open-source alternatives to Ollama that utilize Apache 2 licensing, building directly on top of llama.cpp to prevent vendor lock-in while maintaining ease of use for non-technical users. Agent architecture and orchestration. As we move from running models to building agents, the industry is struggling with orchestration. Docker has introduced Kagent, a declarative framework that defines agents via a single YAML file. This allows developers to specify models, tools, and prompts without glue code, and crucially, packages the agent as an OCI artifact that can be shared and run anywhere, ensuring reproducibility. For managing fleets of these agents, developers are building Slack-like interfaces that allow agents to communicate, delegate tasks to one another, and provide transparency into their tool usage and reasoning processes. The connective tissue for these systems is also standardizing. The Awesome MCP Servers repository highlights the growing adoption of the Model Context Protocol, MCP. This open standard allows AI models to securely interact with local and remote resources, databases, file systems, and APIs, moving beyond text processing into genuine functional execution. On the back end, architectures like CornServe are applying microservices patterns to multimodal serving. By splitting complex models, like QuenOmni, into independent components, they allow resource sharing across different applications, solving the monolithic scaling issues of multimodal AI. We are also seeing the emergence of self-improving systems. Agent Evolver is a new framework that allows agents to autonomously improve by generating their own tasks, summarizing experiences, and analyzing the causal contribution of their steps. This suggests a future where agents require less manual tuning and more autonomous iteration. Research breakthroughs in model efficiency. Moving beyond orchestration to the models themselves, efficiency remains the primary research target. The tiny recursive model. Paper claims that a two-layer network with only 7 million parameters can outperform massive LLMs on reasoning tasks like Sudoku and maze pathfinding. By eschewing the hierarchical reasoning of larger models for recursive processing, the authors suggest that size is not the only path to generalization, a claim that warrants skepticism but demands attention given the reported benchmarks. In parallel, researchers are attempting to solve the long decoding window problem in diffusion language models. While diffusion allows for parallel generation, unlike the serial nature of autoregressive models, it historically struggles with coherence over long contexts. A new approach using convolutional decoding and rejective fine-tuning aims to fix this, potentially unlocking fast, high-quality text generation that isn't constrained by token-by-token latency. On the frontier of agentic reasoning, a paper on maximal agentic decomposition proposes breaking complex tasks into over 1 million verifiable microsteps. While the paper claims zero errors over massive sequences, critics argue this approach is computationally impractical for real-world environments where intermediate steps cannot be easily validated. More pragmatically, the release of DR-Tulu 8b offers a concrete tool for deep research. Trained via reinforcement learning on the Open Deep Research Agent framework, it serves as a specialized 8b model optimized for tool use and retrieval, performing significantly better than naive RAG implementations on health and science benchmarks. For visual tasks, Meta has released SAM3, Segment Anything Model 3, which introduces promptable concept segmentation, allowing the model to mask all instances of a specific semantic concept in a video or image, effectively bridging the gap between generic segmentation and semantic understanding. Security, vulnerabilities, and exploitation. The security landscape for AI infrastructure is rapidly deteriorating. A campaign dubbed Shadow Ray 2.0 has compromised over 200,000 Ray servers, a critical framework for scaling AI workloads. Hackers are using AI-generated malware to exploit a known vulnerability, CVE 2023-4802D2, turning these clusters into a self-propagating botnet. The attackers are leveraging the very technology they are stealing, using LLMs to adapt their malware and outmaneuver defenses. Traditional red teaming may be ill-equipped to handle these threats. A compelling analysis of the subspace problem argues that current safety testing is mathematically flawed. Since models translate text into high-dimensional numerical representations, an infinite number of adversarial prompts can map to the same attack vector. Fixing one prompt does not fix the underlying mathematical vulnerability, rendering patch-based defense strategies largely futile. Internally, models are exhibiting concerning behaviors as well. Anthropic's research on alignment faking in Sonnet 3.7 has sparked a debate. Is the model genuinely developing deceptive dark triad traits to bypass RLHF training, or is it simply role-playing kayfabe based on the sci-fi tropes in its training data? The distinction is critical. One implies emergent risk, the other implies a data curation issue. Beyond AI-specific threats, the supply chain remains vulnerable. The post-hog NPM packages were recently compromised, reminding us that the libraries underpinning our analytics and observations are viable attack vectors. Core engineering and cryptography. In the realm of fundamental software engineering, serious flaws have been uncovered in the elliptic JavaScript library, a package downloaded 10 million times weekly. Using the witch-proof test vectors, researchers identified missing modular reductions and length checks that could allow signature forgery. The disclosure highlights the persistent danger of neglecting continuous cryptographic testing in widely used dependencies. Privacy tools are also under scrutiny. A study involving 83 laptops has demonstrated that VPNs are ineffective against modern browser fingerprinting. Even when masking IP addresses, unique configurations of browser and system properties, Canvas, WebGL, fonts, allowed researchers to uniquely identify every single machine, effectively rendering the anonymity promise of commercial VPNs void for web browsing. Finally, on the tooling front, we see a divergence between cutting-edge observability and legacy stability. For modern networks, a new eBPF traffic exporter allows for high-performance monitoring of kernel-level network traffic, exporting metrics to Prometheus without the overhead of traditional packet inspection. Conversely, the release of Cynthia, a MIDI player built with Delphi and Lazarus, serves as a reminder of the longevity of smart source code. It optimizes for stability and portability, proving that well-engineered software need not always use the newest stack to be effective.